As we all know, the Ionosphere Committee and previously the Ionosphere Working Group, which was established in 1998. And for this Ionospheric Working Group, it provides the Global Ionospheric Maps and also continue to check the possibility to improve the quality and continuity of provided the final and rapid GIMs. And by now there's, as mentioned before in Manuel's presentation, there are 7 Ionospheric associated analysis centers by now. And for the combination of the IGS rapid and final GIM product, this task was done by University of Warmia and Missouri in Poland. And for the combination of the IGS rapid and final GIM, I would say the IGS GIM is the vertical means of GIMs provided by individual ionospheric analysis centers. The currently adopted vetting method is the so-called GNSS-dSTEC analysis with equal satellite elevations angles along one satellite arc, or the so-called GNSS-dSTEC analysis, which was proposed by UPC and Slant. And for the current IGS combined GIM product, it only includes the rapid and the final GIM product provided by code ESA and JPL as well as UPC. The work we would like to done to propose the updates for the IGS GIM combination, and first we would like to replicate the GNSS-dSTEC analysis method for the rapid and final GIM product. And the second, we would like to introduce an external and independent ionospheric observables for the new GIM combination. For example, the DORIS-dSTEC we introduced here for the following GIM combination. And we would also restructure the software for the GIM combination using C and Python language. And compared to the current IGS combined rapid and final GIM product, which only use the GIM product from 4 analysis centers for our analysis, we would like to extend the 4 analysis centers to the full 7 analysis centers. And first, I would like to give a short introduction on the method for the GIM combination. And first, the GIM combination on the basis of the GNSS-dSTEC analysis. As we can see from the equations on the top, that for the VTEC, for the combined VTEC values and each ionospheric grid points, it is actually the weighted mean value of the VTEC provided by each individual analysis centers to compute the cat weight of each to compute the weight of the ionospheric GIM product from each individual analysis centers. We would like to find and first the VTEC references. For the current GIM combination, as I mentioned before, it refers to the GNSS-dSTEC, which was calculated based on the IGS stations which do not contribute to the GIM combination of each ionospheric analysis centers. In our following analysis, we would like to introduce the DORIS-dSTEC, which is actually totally independent to the GNSS observation data itself. At first, I would like to introduce the DORIS-dSTEC analysis. Compared to the GNSS observations provided by those IGS stations, I would say the distribution of the DORIS stations are quite good, because those DORIS stations covering both the oceanic and as well as the continental regions. And for those DORIS data, nowadays we can have access to about the 8 satellite missions. The one point I would like to highlight is that compared to the GNSS dual frequency observation data, the large relative frequencies between the DORIS L1 and the L2 frequencies which can reach to 5, which I would say is quite good or quite sensitive to the ionospheric analysis. In addition, the standardization of the DORIS data format, which is now is the renexed DORIS-3, which is very similar to this GNSS renext, which means that which should be quite easier for us to do the DORIS data analysis. The last one is that the DORIS data is now available, can be accessed in near real time. I mean, when I say near real time, I mean that we can have the access to those DORIS data with a time latency of 3 hours. For example, such DORIS data can be accessed, available from the Jason-3 and the Sentinel-6A. For the computation of the DORIS-dSTEC, which is quite similar to the GNSS-dSTEC analysis, which have been used for the ionospheric analysis for a very long time. But the point here is that for the DORIS-dSTEC analysis, it only contained the ionospheric information obtained below the new satellite altitude. In addition, the computation of the DORIS-dSTEC compared to those GNSS-dSTEC information, we need to take the satellite PCO corrections here. Before we made the combination of the IGS rapid and the final GIM product, we had first analysis the consistency between the DORIS-dSTEC derived RT-GIM combination as well as those RT-GIM combined by the conventional GNSS-dSTEC analysis. For this analysis, we used about 4 months of data in 2022 using 48 DORIS stations as well as the correlated IGS stations. In this analysis, only the near real-time DORIS observation data from the Jason-3 satellite are used. We can see from here the consistency between two analysis methods can reach 0.8, which convinces our DORIS-dSTEC analysis, which can be used for the following on the IGS GIM combination. For our following on analysis, we introduced, I introduced here in this slide the dataset we used for the IGS rapid GIM combination. We have set 2 tests. The one is the conventional GNSS-dSTEC analysis. As I mentioned before here, we include all 7 ionospheric analysis centers. The second one is the GIM combination. We use the independent DORIS-dSTEC analysis. Here gives the flowchart, and first we have access to those GIM provided by our 7 analysis centers. Then we calculate the weight of each analysis, the weight of the GIM product provided by each individual analysis centers. The output is the first one is the combined GIM, which was calculated by the conventional GNSS-dSTEC analysis. And last one is calculated by our proposed DORIS-dSTEC analysis. Here gives a comparison of the weight we derived from the GNSS as well as the DORIS-dSTEC analysis for all 7 analysis centers. On the left, the weight is derived for using the DORIS data. On the right, the weights are derived from the GNSS-dSTEC analysis. Here is the summary table. So I would like to highlight here for those GNSS-dSTEC analysis, especially in our own analysis, those GIM from code, it always gets the highest weight in our combination analysis. In case of the DORIS-dSTEC analysis, I would say the GIM product from UPC, the GIM product will get the higher score. Here gives an example of the newly combined GIMs on December 1, 2023. Here is, we also made some independent validations. The first one is also the GNSS-dSTEC analysis, but in this way, we only use the independent IGS stations. When I say independent, it means that those stations are not contributed to the GIM computation of each individual ionospheric analysis centers. But the issue here, we can see for the CAS1 as well as the CAS2 combined GIM, the performance is slightly worse compared to the current IGS combined rapid GIM product. We are still working on this to figure out what's the reasons here. In the comparison, we also made an independent comparison with the VTEC information provided by the Jason-3 satellite altimetry. In this case, the performance of our combined GIM is slightly better compared to the current IGS rapid product. So here comes the conclusions. So in this work, I would like to highlight that the DORIS data, which is totally independent to the GNSS observation data itself, which can be used as a good references to be used for the combination of the IGS GIM product. To do this, and we proposed the DORIS-dSTEC analysis method, which was the computation are quite easy, which is very similar to the currently used GNSS-dSTEC analysis method. But I would say that our combined GIM product is slightly worse than the IGS provide the rapid GIM product at the current stage. We are still working on this to reach a comparable performance level of the IGS combined GIM, and we would like to make those newly combined GIM products to the IGS users by the end of this year. Thanks a lot for your attention.